with a moderate flame and observe what happens to the lime water.
Prepared for dry test tube. Test tube number 1, 15 drop of acetone. Test tube number 2, 15 drop of chloroform. Test tube number 3, 15 drop of ethylene alcohol. Test tube number 4, 15 drop of kerosene. Next, put a piece of dry Borax paper into each test tube. As you can see, the acetone turns red, the benzene colorless, the ethylene alcohol turns to red, the kerosene turns to colorless. In a dry test tube, place a pinch of urine and a small amount of soda lime. Heat it over a moderate flame and briefly note the odor of the vapors. Expose immediately the vapors into a piece of litmus paper. As you can see, the litmus paper turns to blue.
At this juncture, we're diving into some fascinating chemical tests. Let's start with the Bilstein test for halogens. In the Bilstein test, we begin by heating a copper wire loop in a Bunsen burner flame until no color is imparted. This step ensures that any contaminants are removed after cooling. We dip the loop in the chloroform and reheat it. If a green flame appears, it indicates the presence of halogens, especially chlorine. This green coloration is due to the formation of volatile copper halides, which emit a characteristic green color when heated. Next, we have the silver nitrate test for halides. For this test, we mix 1 ml of chloroform with 1 to 2 drops of nitric acid and gently boil the mixture. After cooling, we add 10 drops of 1% silver nitrate solution. The formation of a turbid or cloudy solution indicates the presence of halide ions, such as chloride ions. This turbidity is due to the formation of silver halides, like silver chloride, which are insoluble in water and precipitate out of the solution. Finally, let's look at the lead acetate test for sulfur. In this test, we combine 1 ml of 5% albumin solution with 5 drops of 10% sodium hydroxide and 2 drops of 5% lead acetate in a test tube. We then boil this mixture over a water bath. The formation of a black precipitate confirms the presence of sulfur. This black precipitate is lead sulfate, which forms in sulfur, and the albumin reacts with lead ions from